Hi everyone and welcome to Activity 1. This video will talk about central angles and how their degree value relates to the degree value of the arc in the circle, as well as inscribed angles and how their degree value relates to the degree value of the arc. You have part of these notes on packet page 1, so you should be starting there. Anything that's highlighted are the things that you'll fill in the blanks that are in your packets. So to start out, a circle is always named by its center. So in this circle here, we would call it circle P. So in a question, if you just see circle and a letter, that is them telling you what point is the center in the diagram. So circle P here means that P is our center. The first type of angle we're going to look at today are central angles. Angle APB is an example of a central angle. BPC is also an example of a central angle because their vertex is at the center. So a little bit of vocabulary. So a semicircle is just half of a circle. So an example of a semicircle in our picture, we could say arc AB. Now when we say an arc, we just put a little arc above it. Kind of like when we talk about a segment, we draw a segment above it. Arc, you just draw a little arc above it. A minor arc is any arc that's less than a semicircle. So one example of those would be arc AC in our diagram. CB would be another example. Kind of like line segments, how you can put the letters in either order, same thing with arc. So I could have called that arc CA. A major arc is more than a semicircle, so an example of that would be arc CAB. Now notice this one I used 3 letters because if I had just done CB, we would have thought that that was the minor arc there. So by putting in CAB, that then signifies that it is the major arc. So if you have to show direction of where you're going, you can do that with a 3rd letter. And adjacent arcs are just any 2 arcs that are right next to each other, and they would share an endpoint. So for example, arc AC and arc BC. They both share point point C. So our central angle, it's formed when our vertex, so the point of the angle, is at the center of the circle. So all 3 of these angles here are considered central angles. Remember, each of those highlighted parts, you can fill in the blanks that are on your note sheet. The sum of our angles at the center has to be 360 degrees because the angles around a point is 360. Well, all the way around an arc must also be 360 degrees. So because of the arcs, then they're also adding the 360. This 3rd line here is the key one for central angles. The degree value of the arc equals the degree value of the central angle. So for example, if this was 120 degrees, the arc that we're opening up to, so imagine you trace your angle and imagine it's gobbling up an arc. Think of it as like a mouth. This arc would also be 120 degrees. If this arc here was 110 degrees, then this arc would be 110 degrees. And if this arc here, because they have to add the 360, and we already have 230, so this would have to be 130 to get us to 360, so this arc would also be 130 degrees. So let's look at an example. Notice they give us the values for 3 arcs, some algebraic expressions. So this would be 2x plus 5. FG here would be 3x, and GE would be x plus 25. Well, all the arcs together add to 360. So we would do 2x plus 5 plus 3x plus x plus 25 equals 360. Combining our like terms, we would get 6x plus 30 equals 360. we could subtract our 30 over, and that would tell us that 6x is equal to 330. And if we divide by 6, x is just equal to 55. So if we sub the 55 back in for x, 55 times 3 will tell us that this arc is really 165. 55 times 2 will give us 110, plus 5 more will give us 115. And then 55 plus 25 should give us 80. So now we can answer the questions they're looking for. Well, arc EF we already found. That's 115 degrees. Angle FOG. Well, notice angle FOG, the vertex is at the center. So we're looking for this angle right here. It is opening up to the 165. A central angle's measure matches the degree value of the arc it opens up to, so this is also 165 degrees. Next, arc FEG would be this one here. Well, that arc should match the central angle that it opens up to. But actually, in this case, we don't need to work with the central angle because we can just add those arcs together, and we would get 195 degrees. One more example with central angles. In circle O, so that means we know O is the center. Well, if O is the center, that means AC is a diameter because it passes through the center. So AOB is 52 degrees. They tell us AC is the diameter, but they didn't need to tell us that, remember, because we knew O is the center. And we want to find BAC. So we want to find from here all the way over to here. Well, since BOA is a central angle, we know this arc that it opens up to is also 52. Based on the diameter, it has to be half the circle, so that's 180. So if we combine those together, we get 232 degrees for arc BAC. So the central angle is one type of key angle. The other type that we're going to talk about today is an inscribed angle. So a chord is just when you have a line segment whose endpoints are on the circle. So AB and BC are both chords there. When they meet on the circle, it forms an inscribed angle. So an inscribed angle has their vertex that is sitting on the circle. The measure of the inscribed angle is always half the arc it opens up to. So if I knew that this arc was 80, the inscribed angle would just be half of that, which is 40. So this idea that the angle is half the arc is an important one for today. So looking at a couple examples, angle B is an inscribed angle. Its vertex is on the circle. It's opening up to the 150 degree arc. So half of that would tell us that this is 75. C is opening up to the 110. It's an inscribed because its vertex is on the circle. Half of that is just 55. And then the 100 divided by 2 would tell us this inscribed angle is just 50. Well, note the angles in a triangle add to 180, which is half of what the circle all the way around is, 360. All right, in our last example for this video, we've got a diameter CB. Now they really didn't need to tell us that because they told us circle O, we would automatically know CB is a diameter because it's passing through the center. They tell us arc AC is 120, and we want to find COA to start out. Well, angle COA is a central angle. We know from previous slides that a central angle is equal to the arc it opens up to. So part A here is just 120 degrees. CBA is this angle right here. Well, notice it's inscribed. Its vertex is on the circle. It opens up to that 120 degree arc. So half of that would just be 60 because inscribed angles are half of the arc they open up to. Now this last one we want BAO. An important thing to look out for in circle problems is where your radii are because all radii are congruent. So we know all those things are congruent. So because of that, the triangle we know is isosceles at minimum. It might be equilateral. In this case, it's going to be equilateral too, but we know it will be isosceles. So isosceles triangles we've seen have two congruent sides. They also have two congruent base angles. So the angles across from the sides must be congruent. And that's it for our video for activity 1.